So the first question I thought of, Ileana, kind of your presentation made me think of this is, what was the fact that we're sitting in this room with a panel and audience mostly of academics discussing this. Blockchain, in a sense, started as an experiment of sorts, and it has grown and expanded and continues to do so. But experiments usually start in academic arenas, right? But this one has not, and it is growing outside of the academic arena. So there isn't the academic controlled environment. And the contributors to it, the contributors to the core blockchain protocols, aren't academics most of the time. So there's a gap here. There's this divide. And so what problems does that bring up, both for the industry and for the kind of intellectual development of the blockchain, and how do we solve them? So I'll throw that to the panel.
Well, as having been somebody who worked in industry and working with the open source communities, I've noticed that there's a very big divide in those two worlds. My developers would go online and literally check Reddit, and that is a legitimate source for them to get their information. But when you talk to professors and academics, they're really interested in this space, and they have a lot of valuable input, but they have a hard time grappling because the work that they do in blockchain doesn't get recognized. There is no formal publication that's the equivalent of, the Harvard Business Review for all topics blockchain. And I actually heard a professor comment about how uneasy she felt about the fact that her research topic was a derivative of something she read on a personal blog. She's like, do I comment in the comments section and say, hey, here's a link to the extension of this work? So there isn't a real mechanism, at least insofar as I've come across, to bridge those two worlds.
Yeah, I agree with you. And I think part of the problem is what you mentioned, that this wasn't born in a university or at a research lab in a big company. This just appeared outside in the world. So that makes the thing a little bit harder to pick up.
Okay, let's kind of steer topics kind of into more something practical. A number of the presentations touched on different kind of aspects of the blockchain, authorizations, identity, permissionless access. What are some concrete examples that you can give as to how those different concepts have been used into actual use cases in the world?
Okay, so
maybe both successes and failures.
Okay, I will try. So for the permissionless, the successful use case would be Bitcoin, for instance. But for a permission one, the Everledger use case, it's a good example of having like a permissionless blockchain where you can keep tracking assets that are, the asset itself is not controversial, but its provenance could be controversial. So I think that's a successful use case. I cannot think of unsuccessful ones.
And one thing that we've stumbled across a lot is that the proof of work, or whatever mechanism you're using in these permissionless chains, it's not just expensive for those mining on the chain, it's actually expensive to verify as well. When you're talking about IoT devices and we're trying to design extremely low power, highly embedded systems that are participating in the chain, the algorithms, for example, used by Ethereum are actually very difficult to verify. They take a lot of computational power. Because if the algorithm were insufficiently complex, so Ethereum pulls in a bunch of other states as part of the verification, and that's all to make it ASIC hard and so on. So there's this constant trade-off. If it were a permission system, proof of authority, those signatures could be extremely cheap to verify. Your cost of participating in the chain, not as a miner, but just receiving data from the chain, would be way lower. So there's a trade-off there too.
In your research, you touched on kind of democratized global access permissions. Have you looked into a lot? The Internet of Things is obviously something that comes to mind for that. Do you have any use cases that you've really seen where this works using that?
Yeah, so the area that we're focusing on a lot is the built environment and the Internet of Things. So a lot of the sensing infrastructure in cities is tied to buildings. It's sensing of environment in rooms to try and improve occupant comfort and so on. And the way this data is all stored, it's all very centralized. There'll be a single server in a building storing all this information. But as we start to try and get better energy efficiency at the scale of cities, there's a lot of desire to build applications that run over cities. Things like demand response, as the power grid is struggling, and as solar and wind generation changes, you try and get the city to coordinate and change its power consumption patterns. And that requires coordination. Of these buildings are owned by different people who don't trust each other and don't care about each other, but you need an application that can access and control across all these different spaces. And so you need an authorization system that can go across all of this. And as Brian mentioned earlier, you can't find one organization to be the authority for all of this, so a blockchain is a logical choice there. And so that's where we've been investigating.
Okay. So we have some use cases. I mean, I'm not an academic. I'm not the expert on blockchain, but I know when blockchain started, the theory behind it, and then learning it, and now we have use cases. I think a lot of the issues that even clients that I'm working with kind of face now is scalability. And so we have some use cases, but how do we get it to be this thing that everyone wants blockchain to be? What are the big impetuses to scalability, and how do we get over them?
So, for example, in Bitcoin, you have this Lightning Network. So you have the main blockchain of Bitcoin where you have these writings, which summarize transactions. And the Lightning Network enables people to have off-chain transactions, let's say for 1 month between two participants or several participants. And these transactions are not seen by the main blockchain, which has a very low bandwidth. But you can have a lot of off-chain transactions, and at the end of the month, you have some kind of wrap-up situation which is cast to the blockchain. This means you could have a very high volume of financial, or let's say Bitcoin exchange between participants. It will not be seen by the main blockchain, so it will be very good privacy, and it could, with a very large number of users and transactions. So the Lightning Network is a very big thing, in my opinion, to have Bitcoin scaling for everyone.
And I think the thing there is that model works very well for financial transactions. Yes. But when you start to look at these other applications of a blockchain, for example, storing authorization, the security guarantees are inherited by the fact that if something happens, some permission changes, that's globally visible. There's that global state, which means that these kind of state channels, these side chains, they achieve scalability by hiding some of the state, which undermines some of the use cases. So it is a problem that we still need to do a lot of research in. Not sure.
It's use case specific, but it's also driven by the incentives of the parties. So in the state channel implementation, you wouldn't use it for absolutely every single scenario, but only the ones where for both of the parties there's enough of a reputational danger to being the malicious actor, and so you're putting the more mundane things off chain.
Yeah. But also you can, besides the side chain, you can try to mix two blockchains. Let's say you have a private blockchain inside or a permission blockchain, and you want to put outside evidence that something happened. You can put that evidence in a public blockchain like Bitcoin, like making a hit or a milestone that something happened without all the burden of constantly transacting on a blockchain, a public blockchain.
Okay. So another question I had. We hear a lot about, and we've talked a lot about, the promise of blockchain and the various applications what all we can do with it. But I think there are also some harms, right, and costs, or potential social and economic harms and costs. And unless we address those and identify them and then address how to get over them, whether it be the actual economic costs or kind of social harms affiliated with identity and anonymity, unless we address those in a responsible way, then that could be a hindrance to actually the blockchain fulfilling all of its potential and all of its applications. So what are the social and economic harms and costs that you most worry about, and how do we overcome them?
So I mean, just to start that off, I think for us, if you have a permissionless chain, it has to reach a certain scale in order for it to be secure. If I take Ethereum and I create my own fork of it and I've got 10 people participating, then any well-funded person can jump in with enough hash power to completely run the chain, right? So you have to have a ton of people mining on it, and that means you're burning energy to keep it going. And so there's this trade-off of these applications are trying to achieve social good. You know, a lot of our focus is energy efficiency in the built environment, but you're burning massive amounts of energy in maintaining the chain. So there's that.
Okay, I have a slightly different, not contradictory point, but a very different perspective. When we think about Bitcoin and its ability to enable populations who don't have as many financial services at their disposal to participate in the financial ecosystem, that's great. But the average layperson is not highly technical. And what we're asking people to do in a blockchain environment is to manage their own personal digital assets with as much care, actually greater care than anything else that they've ever owned. Because as consumers, we have this tendency of being able to, call the bank, call someone else, click a button that says, I forgot my password. And there's a lot of education that still needs to happen at the consumer level and kind of extra safeguards that need to be introduced by companies that operate in the space to make sure that you don't end up with Granny over there losing her retirement savings because she fell prey to a phishing scam and accidentally disclosed her private keys. So that could be one kind of scenario of evil.
Yeah, that's very true. I mean, even in my own circle of friends, the number of my friends who have lost significant amounts of Bitcoin just because they lost their keys is way higher than because exchanges were hacked or anything. There's no point of recourse. So with this crypto system, if there's no authority, there's no one you can go to and say, oh, I lost my bank card, can you give me a new one? Yeah, it's gone.
And whether it's financial or kind of your reputation or identity, I think you're going to hit some risks or some friction there, right? Because some companies obviously want that data. They want the control of it. They don't want to give that up. Once consumers have more and more of it, those companies have less and less control. So there's going to be friction there as those two things develop together. That's true.
Yeah, and I think, oh, sorry.
Oh, it's okay, same story as you. I wouldn't say cost, I would say risk, actually. Because as you said, things are about the security risk, actually. And so I have the feeling, so the Bitcoin was designed, the crypto and the system, to protect Bitcoin, but not the users. So there was no Alice and Bob. But it's like a banknote. If you lose $100, it's like the central bank will not fail, Federal Reserve will not fail, but you are failing. Yeah. So there are a lot of potential risks for users, and that is something we could hinder the adoptance on a large scale of blockchains.
Yeah, no, agreeing with you that one potential harm is when the asset you are managing on the blockchain network is your identity. So if you have some problem losing your identity or having it stolen or the private keys to access your identity stolen, you don't have a fallback. You don't have a way to recover from that. You cannot rebuild your identity in the real world.
Okay, I know we have well, at least for the first speaker, we had a pretty hot room with questions, so I wanted to go ahead and open it up. If anyone in the audience has any questions for anyone on the panel.
Hi, my name is Vijay. Talking about the future of blockchain and considering all the energy and computation power that is required to maintain consensus, I was wondering what are some new algorithms like proof of work, but that is not so computationally intensive, and at the same time being able to address the Byzantine general problem?
So I think the two that we've, in my research group's been looking at is, so there's long been an interest in a proof of stake, which is basically your risk instead of being a real world asset like energy is in the crypto chain. But it's very complex to do the game theory analysis and get the soundness guarantees there. So I still think that's a little ways off. If you compromise on some of your security guarantees, you can do something like, for example, Sawtooth has a proof of elapsed time by trusting SGX, which is a primitive in the silicon. So assuming that's not compromised, and if your silicon's compromised, that's the least of your worries, then you can basically get the same kinds of guarantees, but with far less energy expenditure. So that's another avenue.
Okay, so I'd like to mention, well, it's only a paper, it hasn't been implemented, but it's called Permacoin, and so it's from Microsoft. and it's you try to use mining for some public good. So mining will have two purposes: managing the blockchain and maintaining the integrity of the blockchain, and at the same time doing something useful. So it is this permacoin. So you don't use also computational power, but you use storage. And for instance, you will have to prove that you store part of the Library of Congress. Okay, so that will be the service you will bring to as public good, and you can transform that in a mining algorithm to certify blocks. And so your work will do the public good of managing on a peer-to-peer basis the Library of Congress, but also certifying the blockchain. Some economists are saying that it's not possible, that by design, if you work for certifying the blockchain, it cannot be useful for something else, so it's not clear. But there are a lot of research, well, no, there are quite a few papers on other way of trying to get the consensus. So you have the proof of something, you have proof of storage, proof of work, proof of stake, proof of mini proof of something. That's one thing, but maybe you can have another view of the notion of consensus and something more different. Okay. So, but that's research, I would say.
Other questions?
If someone wants to do something with this, can they estimate if something is valuable? Or that's not the word I want. Is it too expensive? Is the proof of work too expensive? Is the blockchain too slow to update? Is your identity not secure enough? Are there floor requirements that you can say, well, this would be a viable project and this wouldn't because the technology just isn't there yet?
Well, to give you the classic consulting answer, it depends, right? So for every single use case, there's almost this decision tree that you go through of, do you need a blockchain, right? And one of the first questions is, do you have multiple parties? Do they not trust each other? Is it potentially going to be more effective to have this done in a decentralized manner than a centralized manner? If you answer yes to most of those questions, then you move on to the next piece, which is, well, what would you theoretically need to build? And what are the various components that you need to pull into the equation? And what are your performance requirements? Is this a network that's going to process 5 transactions per day? Or is this a network that's going to process 5 million transactions per hour? And depending on each of those answers, you'll end up using a different blockchain infrastructure. You may end up using different middleware components. You may end up having to build pieces yourself. You may be able to borrow other integration endpoints to get into your existing legacy systems for this whole model to work out. And in every use case, there are trade-offs. So you either want more security or you want more speed. Like that imaginary triangle, you can usually only get 2 of anything.
Yeah. And I think that decision tree speaks to somewhat what you were talking about, Diego, kind of the diagram you had when you're deciding between even, for instance, permission or permissionless, right? There are different attributes that you need to decide whenever you're deciding whatever problem it is you're trying to solve. It's just one specific example of a decision you'd have to make.
Yeah.
Anyone else?
I think there's one down here.
Oh, thank you.
Hi, I'm Hannah. I have a question for computer scientists. I wanted to know, how do you define identity? What is your definition? Thank you.
So that is a very complex question, actually. And so the way in our deployed system, the way it's done is you have this key pair, and whoever possesses the secret part of that, that is what that key pair represents. So that may be a running program, it may be a person, maybe a device. And I think that's the most obvious way. But as talked about earlier, there's a problem. If that key pair, possessing that key pair, represents your identity, and that gets compromised, what recourse do you have? I mean, normally if it were your birth certificate, you could go and get your fingerprint scanned or a DNA test, and some authority could say, okay, we'll rectify this. But if it's possession of a key pair and that gets compromised, then what? So it's an unsolved problem from my perspective.
Yeah.
I am not a computer scientist, so I'm not going to answer that.
These ransomware attacks seem to rely on Bitcoin, and I'm wondering whether we're actually going to see physical kidnapping relying on Bitcoin, and wondering what the people involved in the business are thinking about how to deal with the criminal prospects of using Bitcoin.
Maybe assassination politics?
Pardon?
Talk about assassination politics?
All right, so let's kick this off without talking about assassination politics. So first things first, you can't design a system that enables all sorts of good users to do good things while also eliminating the possibility for malicious actors to do bad things. Currently, ransomware is not a new concept. In fact, there are companies out there that do ransomware as a service. And that has existed even before the introduction of Bitcoin. Previously, what was the most commonly used way of paying ransoms or any other illicit activity? Usually the US greenback, cash. It's really hard to trace. Bitcoin does make it easier, in theory, to go and pay these ransoms, partly because the amounts that are being requested are fairly minimal. And for a business owner, if you're faced with, I have all of my important business files encrypted, and I either pay $1,000 or I don't pay $1,000, the answer is usually, if I don't have a backup, I'm going to go pay the $1,000. For that small sum of Bitcoin that you're paying in ransomware, you're probably not kicking the door down at your local investigator's office to try to trace the value of that payment. But theoretically, because Bitcoin is on an open distributed ledger, you apply enough analytics to it, and there have been instances where law enforcement has been able to trace with reasonable assurance where some of the funds may have gone, assuming that there is an entry point into the blockchain ecosystem and there's an exit point where eventually maybe they wanted to cash out and actually get fiat currency back. So ransomware has existed for many years. It will continue to exist. Hopefully it doesn't get into kidnapping territory, but
you know, I think that's a specialized form of a more general problem that has existed forever, is that if you design a democratized system where all participants are equal, then that means the bad participants have the same utilization of the system as good participants. I mean, if you look at Zcash, they've gone to great lengths to be able to allow these zero-knowledge transactions, but that means that the system is also great for illegitimate transactions and you know, criminal networks and whatnot. But it's very difficult to design a system, I would argue maybe even impossible to design a system that only allows good participants to remain anonymous, untraced and whatnot, but the bad participants, you know, then we can control them and whatnot. So yeah, you've got to take the good with the bad.
So we are touching on social and legal issues, actually. Like any technology could be used for good or evil, and then it's a society who has to take, and the law and the lawyers to take, and police to be in charge of that and controlling what's going on. So, for instance, I think the director of CIA say to prevent ransomware, there should be more friction between the Bitcoin world and the classical financial space, so that it will be more difficult for people to pay ransom, because more trouble to get Bitcoin because it will be complicated, and so less incentive for ransomware to make these viruses and so on. So, you could control on the margin of the system. And I think it's not technology by itself who can control that, but more law and police and so on.
There's also an inherent contradiction in ransomware and Bitcoin, because oftentimes the organizations or people that don't have their files encrypted are naturally going to be less technologically savvy. And yet you're asking those less technologically savvy people to go and get Bitcoin, which arguably already has a lot of friction in the ecosystem, to go and get Bitcoin so then they can pay their ransom.
I think we have time for one more question. Oh.
I'm coming. Oh, right there, right next to me. Here, this way.
Thank you. Okay, I'm going to throw this out. I don't expect an answer immediately for reasons that will be obvious from the nature of the question. But if you build a big, democratized, complicated system like this, and it is going to have to be reliable and usable by people who do not have PhDs in data science. So I'm going to throw this out as a challenge, and maybe you can answer me in a few years. How do you get the UX to the point where people who are still using the same password on all their bank accounts can use it reliably and safely without ruining their lives? As I said, don't hurry on the answer, but I want it out there.
Yeah, it's a fantastic question, and I think it's a kind of a chicken and egg situation. What motivates people to improve user experience is the fact that a system is being used, but the system needs to be used in order for that to happen. But I think we started to see some of that. Even if you look at Ethereum, just a year ago, using Ethereum, participating, making transactions, and interacting with contracts basically required you to know how to program. And now we've got to the point where you can install a browser plugin, MetaMask, and you can interact with contracts and do transactions from your browser. Or you can download Mist, and you get like a nice browser that has this functionality built in. And so I think it's progressing, and the more interest this area receives, the more people will be motivated to invest the time into doing that kind of thing. I will say that I think a lot of this is going to come out of startups and industry, because, as was mentioned earlier, it's actually difficult to get funding for this kind of thing in the academic area. So we do it as part of other projects, but to just look at that problem in isolation is quite difficult.
Thank you.
All right, I think we're out of time, so thank you all for the panelists. Thanks.